Hello class, we're about to start section 3.4, Value, Interest, and Mixture Problems. Problem solving method. To solve the problems in this section, you will need to identify two variables and write two equations that give relationship between the variables. Step 1, define each variable. Step 2, write a system of two equations. Step 3, solve the system. Step 4, describe each result. And step 5, check. Now let's take a look at this first problem. We have type 1, value problem. You are managing a performance for a popular band. You booked a 20,000 seat amphitheater where the band will perform and expect a sellout crowd. Market research indicates that buyers are willing to pay. Now, if you notice, I put this $75 in red. I believe on your worksheet it says $50, so I need you to switch those values. The values I have in red, I need you to change those values on your sheet. So this says 50, you need to change it to 75. And I believe this says 75 and you need to change that to 50. So it indicates that buyers are willing to pay $75 for better seats and $50 for seats further from the stage. Your goal is to take in $1.2 million from ticket sales. How many seats should you designate at each price level? Okay, now, the first thing we have to do is this here. We're still dealing with a system of equations, but this is the real life application of the system of equations. So we have step 1. Now we have x is equal to better seats Okay, class, I went back and what I did here was I typed in this information because for some reason things were starting to disappear. So this is step 1. X is equal to how many better seats. Y is equal to how many further seats from the stage. Now, we want to put this together in step 2, write these in the equation. So we know the price of the better tickets is $75. The price of the tickets that are further from the stage are $50. And we know that when we add these two ticket prices together and the amount of tickets sold, we want to earn 1 million, I forgot a zero here, 1,200,000. Okay, now for our seats, we know we only have 20,000 seats. We only had 20,000 seats. So we'll take how many better seats we have plus the amount of further seats we have, and that should give us 20,000 seats. Now, step 3, we want to solve this. Now, we could use our system of equation. We could use either the elimination or substitution method. I would suggest using the substitution method. And I would take a look at this second equation here. And let's get y by itself. So we'll subtract x on both sides. So now we will have y is equal to negative x plus 20,000. Now what we need to do is substitute this value in for the y in the top equation. So I'm going to write it up here to give myself more space. So I will have 75x plus 50 times, it'll be negative x plus 20,000, and that is equal to 1,200,000. Okay, now we will have 75x. 50 times negative x will give us a negative 50x. And then 50 times 20,000 will give us 1 million. And that's equal to 1,200,000. Okay, now 75 minus 50 will give us 25x plus 1 million. We can put those commas in there. Is equal to 1,200,000. Now we will subtract 1 million on both sides. We will have 25x is equal to 200,000. We divide each side by 25. And x is equal to 8,000 seats. Now, since we have 8,000 seats, and this will be at $75. We have 8,000 seats at $75. We know we only have a total of 20,000 seats. So then our Y would have to be 12,000 seats at $50. And this here is our final answer. And this right here will be considered step 4. The final answer is step 4. Now we start example 2. It says, when investing money, you must balance the growth potential of the investment with the risk involved. Your financial goal is to have $50,000 to cover your child's expenses 10 years from now. You plan to place some money in a conservative investment with an average return of 5% annually. You are willing to invest twice as much in a higher risk investment that is expected to yield a 9% return. How much must you invest in each account in order to meet your goal? Now there is one sentence you need to add to this scenario, and I have it here in red. Now what you need to do is pause this video and then write down this sentence. Okay, now this is what we need to do. We need to go through our steps again. Okay, now we know step 1 is we will label the variables. So we have x is equal to how many dollars are at 5%. And then y is how much money you put at 9%. Okay, step 2. We have this here. We have these stipulations here. So we know for the 5%, you're willing to put twice as much in it. So you have 2x is equal to y. Now remember, we're talking about how much money you're putting in each account. So you will have twice as much money you will put in the 5% account as you would the 9% account. Okay, so now we have our interest. The interest will be 5%, so it'd be 0.05x plus 9%, which is 0.09y, and that must give us a yield of $1,950. Now, so we will go through here and do this. We could use substitution since we already have this set up. Y is equal to 2x. So what we could do in this problem here, we'll substitute in 2x for y. So now we'll have 0.05x plus 0.09 times 2x is 0.18x, and that equals to 1,950. Now we will combine like terms. We have 0.23x is equal to $1,950. Now we will divide each side by 0.23. And we will end up with x is equal to, now this would be $8,478.26. Now remember, this is at 5%. Now our y value, remember, we invested double this value into the okay, class, I need to go back and clarify something. I made a small error here. It says in here, you are willing to invest twice as much in a higher risk investment that is expected to yield 9%. So when we have 2x is equal to y, this y value, or the 9%, you will have double the amount of money in the 9% account versus the 5% account. So what you will have to do is this here, since the 5% account has $8,478.26 in it, then you need to double that, and that will give you how much you will have at the 9% account, which would be $16,956.52, and that will be at 9%. And this here is your step 4 and your final answer. Okay, now we come to example 3. It says a chemist checks the storeroom and discovers that she has 10% alcohol solution and 30% alcohol solution in stock. The procedure she wants to carry out requires 10 ounces of a 22% alcohol solution. How much of each stock solution should she mix to get the result she wants? Okay, step 1. X is equal to how much of the 10% solution in ounces. Y is equal to how much of the 30% solution in ounces. Now, step 2, we're going to write our two system of equations. Now, the first equation we're going to write out in ounces. So we know we wanted to end up with 10 ounces of a 22% alcohol solution. So we'll take how many ounces we had for 10% plus the ounces we have for the 30%, and that should give us a total of 10 ounces. So that's why we get the x plus y equals 10 ounces. This OZ, that means that's the abbreviation for ounces. Now we come to the percent of alcohol. Now we know we have a 10% solution, alcohol solution, so it'll be 0.10x plus the 30% alcohol solution, which would be 0.30y, and that's supposed to equal to a 22% alcohol solution, which is 0.22. Now we have to multiply this by 10, because remember, in chemistry we have to write down what we're trying to find. We're trying to find a 10-ounce solution of the 22%. So that's why we have 0.22 times 10. Now, when we multiply that out, we know that this is equal to 2.2. So this right here is 0.10x plus 0.30y is going to equal to 2.2. Now what we have to do next in step 3, we know we need to solve the problem. So I suggest we do the substitution method. What we could do here is we could get y by itself. So we could take x plus y is equal to 10, subtract x on both sides, and we have y equals negative x plus 10. So now we would take and substitute in this negative x plus 10 into this second equation. So we have 0.10x plus 0.30, and y is equal to negative x plus 10, and that equals to 2.2. So we have 0.10x. Now 0.30 times a negative x will give us a negative 0.30x, and 0.30 times 10 will give us 3, and that equals 2.2. So 0.10x minus 0.30x will give us a negative 0.20x, plus 3 equals 2.2. Subtract 3 on both sides, and you add negative 0.20x is equal to a negative 0.8. Now we divide each side by a negative 0.20. So we would have x is equal to 4 ounces at 10%. And since we know x plus y is supposed to give us 10, we know that y is 6 ounces at the 30% solution. So this is our final answer. So we have x is 4 ounces at 10% solution, and y is 6 ounces at the 30% solution. And we're done.